Hi friends, let us start today new chapter 13 nuclei. In previous chapter we had already learned about the nucleus, about the atom, structure of atom and different models. J.J. Thomson's model, then Rutherford model and then Bohr model. So according to this model, now we know it that the atom is made up of electron, proton and neutrons. In the center there is a nucleus, and nucleus carry nucleons. So what do you mean by nucleons? Nucleons means proton and neutron which are inside the nucleus. That is, they are said as nucleons. Protons carry positive charge and neutrons are neutral. And both proton and neutron masses are nearly equal and they are much heavier than that of the electron. So most of the mass is concentrated in the center of the nucleus, and the size of the nucleus is nearly 10 raised to 4 times smaller than the size of the atom, right? And the mass is mainly concentrated in the nucleus. So that is why the volume of the nucleus is about 10 raised to minus 12 times. These two numbers are important for MCQs. So volume of the nucleus is about 10 raised to minus 12 times the volume of the atom. It means we had learned it that most of the atom is empty, right? I told you that imagine the atom like a football ground, and in the center of that there is a football. That is the size of the nucleus. So the rest whole part is nearly empty. And as I told you, electrons are much lighter than neutrons and protons. So more than 99.9% mass is concentrated at the center, and that is the nucleus. So let us study in this chapter in detail about nuclei. It's a plural of nucleus. So we know it. The proton and neutron. In 1932, Chadwick, it's the name of a physicist who discovered neutron. So we know it that there are Z number of protons and same number of electrons in an atom. As electrons carry negative charge, protons carry positive charge, atoms are neutral. A is called as the mass number. What do you mean by mass number? This Z is called atomic number. Z atomic number. I repeat, what is atomic number? Z, number of protons or electrons, and that is plus Z charge, minus Z charge. Total charge on atom is 0. A is the mass number. What is mass number? That is total number of protons plus neutron. So it is clear that there are Z number of protons and Z number of electrons, and number of neutrons are A minus Z. Right, students? Then proton, as I told, it's a fundamental particle of nucleus, and in case of hydrogen there is only one proton and there is no neutron. Both mass of the proton is 1.6 into 10 raised to minus charge of the proton is 1.6 into 10 raised to minus 19 coulomb, and mass of the proton is 1.67 into 10 raised to minus 27 kg. Now see, the proton has positive charge, electron also has the same charge, but it will be negative. And the mass of the proton and mass of the neutron are nearly same, and that is nearly 1836 times heavier than that of the electron. And protons has angular momentum that is equal to half. It also possesses magnetic moment, and it is much smaller than that of the electron. Remember, we had proved it, magnetic dipole moment is EVR by 2. Here it has both spin angular momentum and it has magnetic moment also. Neutron. So what are neutrons? So they are chargeless particle, and its mass is nearly of the order of neutrons, slightly, very slightly. See, 1.67 to 1.67, it is 49. That is the only difference. So you can consider for numerical purpose their masses are nearly same. It has intrinsic, that is spin angular momentum, that is equal to that of the proton, and it is neutral, but still it has very little magnetic moment. So neutrons and protons are nearly considered same because of their mass. Now electron, we have already learnt that it is a negatively charged particle. It carries the charge minus 1.6 into 10 raised to minus 19 coulomb, and it revolves around the nucleus in different stationary orbits. As per the Bohr, the stationary orbits are those orbits whose angular momentum is integral multiple of h by 2 pi. Now see, this nucleus, inside the nucleus, actually there should be you have learnt in electrostatic chapter that proton positively charged particle, they should repel each other, but in fact inside the nucleus, we are going to study in detail later on that nucleus are very dense. So in spite of positive charge, in spite they should repel, the all protons and neutrons remain or bounded inside the nucleus, and that the strong binding force which binds all the nucleons together is called nuclear force. We will study that in detail later on. So let us study the important terms. Already I told you, nucleons, proton plus neutrons, atomic number, number of protons or number of electrons denoted by Z, mass number, total number of protons plus neutron, or you can say total number of nucleons are denoted by A. So number of protons Z, number of electrons Z, number of nucleons A, number of neutrons N, A minus Z. Nuclear mass, that is mass of neutrons plus proton, or you can say mass of the nucleons, nuclei. So it is an atom. In basically see, the atom, it is talked with particular reference to its nuclear composition. That is what we say it nuclei. Any atom is represented symbolically. The atom is X, Z, A. Z atomic number, A atomic mass. For example, 79 AU 197. So it's a atom of gold AU. 79 is Z, that is number of protons or number of electrons, and 197 is the number of nucleons, proton plus neutron. 197 minus 79 will give you number of neutrons in that atom. Let us study now in detail about what we mean by isotopes. So we know it. What are isotopes? So isotopes are nothing but the atoms of an element. Remember, it is of a given element. Those who have same Z, same atomic number but different mass number. So atoms having same Z, same proton but different mass number, different A, are called isotopes of each other. Say for example, hydrogen, it has 3 isotopes. This is known as protium 1H1. This is known as deuterium 1H2. This is known as tritium 1H3. Protium, it has 1 proton, 1 electron, but no neutron. 1H1. 1H2, 2 because 2 nucleons, 1 proton, 1 neutron, 1 electron. Tritium 1H3, 1H1, 1H2, 1H3. So it has 1 proton, 2 neutrons and 1 electron. So 1H1, 1H2, 1H3. Protium, deuterium, tritium. These are known as isotopes of hydrogen. Same way you can see here, say we have isotopes of lithium. Lithium, you know, Z is equal to 3. So this positives, circle with this positive are protons. Circle with electron, negative charge, electrons. And the empty ones are neutrons. So 3 proton, 3 neutron, and in the orbits 3 electrons. You know it, there can be 2n square number of electrons in a given orbit, where n is the principal quantum number. So first orbit there can be only 2 electrons. The third electron will be in the second orbit. Here you can see there are 3 protons, 3 plus 4 neutrons and 3 electrons. So 3 Li6, 3 Li7. These are the isotopes of lithium. There can be, you can give any example for isotopes. The concept is same number of electrons but same Z, same atomic number but different mass number. Now see this, why the isotopes and what we are going to study related to that in detail. So see here, isotope, in Greek isotope means the same place. So they occur in the same place in periodic table. That is the word isotope in Greek, same place. Isotope, same place. Now see here, the periodic table suggests that every element consists of a mixture of several isotopes. Relative abundance of different isotopes differ from element to element. Means, say they have given you the example of chlorine. Chlorine has 2 isotopes and their atomic masses are 34.98 U, 36.98 U. So what is this U? So understand that U is nothing but atomic mass number. So what is the atomic mass number? It is, initially it was labeled as AMU, but now it is labeled as only U, atomic mass unit. How we define it? So it is defined as 1/12 of mass of a carbon. Why we had selected carbon? Because we know it, carbon is abundantly found in any living or non-living organism. So 1/12 of carbon C6 12 is the considered as the reference, and 1 AMU, one atomic mass unit, 1 U is mass of carbon divided by 12. Why we are dividing it by 12? Because we have chosen the isotope of the carbon which has 12 nucleons. So when you do the division, you are going to get it is at 1.66059 into 10 raised to 27 kg. So this conversion, you should know it. It is like a mass of one proton, 1.66 into 10 raised to 27 kg. So in that term, in atomic physics, we consider the mass of any element in terms of U, integral multiple of mass of hydrogen. So the atomic mass of chlorine is 35.46 U. Remember, atomic mass of chlorine is 35.46 U. So how it has come? So chlorine has two isotopes. Both isotope has different masses. One isotope 34.98, another isotope 36.98 U. Right? But their abundances are different. Means the abundance of this isotope, the first isotope abundance is 75.4%, while second isotope abundance is 24.6%. Means in nature, this isotope of chlorine, whose atomic mass unit is 34.98, is found nearly 75.4%, while the one which is having atomic mass unit as 36.98 AMU is 24.6%. So if we calculate it, this multiplied by 75.4% plus this multiplied by 24.6%, obviously percentage is per 100 divided by 100, we are going to get the atomic mass unit of chlorine, that is 35.47. That is what we know it. So any atom which is obtained in abundance, right, there different isotopes may obtain in different percentage in nature, and that is how we do the calculation and find out atomic mass unit of a given atom. Here they have given another example. We learned it. Isotopes of hydrogen, 1H1, 1H2, 1H3, protium, deuterium, tritium. So mass of protium is 1.0078, deuterium 2.0141 AMU or U, and tritium is 3.0160 U. But the abundance of this 1H1 is 99.985%. That is the maximum. Deuterium and tritium, these are very less, right? They are very unstable and they do not occur naturally. This 1H2, that is deuterium and tritium, can be artificially obtained in laboratories. We will study that later on, how we can do that. So the AMU, atomic mass unit, U, of hydrogen is nearly because of this, and that is why 1.007, and that is nothing but the mass of the proton, 1.67 into 10 raised to minus 27 kg. I hope you are getting this. Now see, we will go for isobar. So what are isobars? The atoms which are having same mass number, matlab A is same but Z is different, they are called isobars. Since Z is different, number of electrons are different, and number of electrons decide the chemical properties. So here chemical properties of isobars will be different, and they occupy different position in periodic table, unlike isotope. So see the example, 1H3, it is 1H3 matlab tritium, and 2He3. These both are isotopes of hydrogen and helium, different elements. But see this 3 and 3. A, that is atomic masses are same. Same way chlorine 17 Cl37, sulfur 16S37 for A 37. Same way you can write any example, 20 calcium 40, 18 argon 14. So they have same A as 40. So these are isobars. Now let us go for isotone. Isotone, here they have different number of A and Z, matlab atomic mass and atomic number are different, but number of neutrons are same. So the nuclei having same number of neutrons are called isotones. Nuclei having same number of neutrons are called isotones. So see here, 37 minus 17, 20. 39 minus 19, 20. So both these nuclei have same number of neutrons, and that is why they are called as isotones. And the last one, see this is the another example, 80 Hg 198 minus 80, 118. Plutonium 79, plutonium 197. Subtract it, you are going to get number of neutrons as 118. And the last one, isomers, this you have done it in chemistry in detail, we are not much worried about this in physics. These are the nuclei with same atomic number, same mass number, but different energy state, and they have different structural formula. So the nucleus in its ground state and the identical nucleus in meta state, that is excited states, they are called as isomers. I hope it is clear.